Welcome back to the channel, folks. Wildlife Ranger here on YouTube. I hope today you can join me on a trek to find yet another plant in the Spring Botany series. Today we set out to find and look at the habitat of a plant known as common lungwort, or Pulmonaria Officinalis. Much of lungwort seen throughout Britain is that of an opportunistic escapee, and therefore it is difficult to be prescriptive on the habitat where it may occur. What can be said, however, where it is found, is that it is found on shaded or semi-shaded habitats on humus-rich soil. The plant itself can seed some considerable distance away from any horticultural activity, and those places include riverbanks, streams and westside, damp edges of ponds, hedgerows and humus-rich damp churchyards. So the variety of habitat is considerable, providing the physical conditions are met. In the case of our spring video, taken on the 14th of April 2025, we find 4 to 5 stands of lungwort on a rich soil in a quiet corner of a disused churchyard. As can be seen, the flowers are a welcome source of nectar for the early spring bumblebee. Common lungwort is also referred to by a number of common or vernacular names. It is thought that the term lungwort is derived from the leaf's appearance of many spots resembling ulceration of the lungs. The other common vernaculars, such as Joseph and Mary and soldiers and sailors, reflect the colour changes in the flowers as it blooms. The Latin is straightforward, pulmonaria, meaning of the lungs, and officinalis, as assigned by the taxonomist Carl Linnaeus, giving credence to his doctrine of signature in this mucilage-producing plant. As always, before we begin our journey into the field, let us look at the features and characteristics which will enable us to identify and find it, beginning with the flowers and the leaves. The flowers of lungwort have an interesting tale to tell. The 5-petal flowers are red or pink at first, later turning to blue or purple during the flowering period. And they do this by changing the pH value inside the petals, because they contain a dye-like substance that belongs to the anthocyanins, and this changes the colour from red, which is acidic, to blue, which is alkaline. Turning our attention to the flower detail, lungwort is a member of the family Boraginacea, or the borage or forget-me-nots. It's typically a ground understory plant growing up to 30 centimetres high. It is also an early spring flowering plant, vital for nectaring bumblebees who cross-pollinate the flower. Flowers of this plant start out reddish or pink initially, turning to blue or violet as the flower blooms. They are approximately 13 to 18 millimeters in size. As stated, they start off as pink and change to blue due to age-related pH changes in the petals. They bloom in clusters. It has 5 petals with a funnel-shaped flower tube, each containing 5 stamens. The sepals have long calyx and shorter triangular teeth and occur on the leafy clusters. While it's not immediately obvious, this plant has different lengths and configurations of stamens and styles, preserving genetic diversity through a process known as hydrostyly, which we dealt with in the primrose video when we studied dimorphism, where we looked at the visual indicators of the pinnae and thromi form of the plant. The phenology of this plant, i.e. when it flowers, is between the months of March, April and May. Turning now to the leaves of lungwort. The leaves are semi-evergreen, are typically cordate, i.e. heart-shaped at the base, and the stem leaves oval, on stalk, clasping the stem with entire margins on their edges. They have a distinct ornate splodge of variegated white on the upper surface, making them easily recognisable as a plant. So I hear you ask, why are the leaves of lungwort spotted? Well, that's a complete video in its own right, but let's try to give a simple and short answer. Lungwort leaves are adapted to come into leaf before the full tree story is present, therefore exposing the leaves in the plant to potential temperature and UV harm. The spots in the leaves are due to foliage air pockets which cool the lower leaf surface and mask the presence of the green pigment known as chlorophyll. So the short answer, it's due to cooling, and there are other adaptations in the leaves that protect it from ultraviolet light. Well, that's it from me, folks. Thank you very much indeed for watching. If you have liked this video, please like, share and subscribe and help this channel become a success. With spring firmly underway, I do hope you can join me on the next track where we may find the next plant in the beginner's guide to spring botany. So until the next video, stay safe, enjoy the sunshine, and we'll see you soon. Thank you again for watching.